Video, I'm going to do a little bit more with completing the square. So first, let's just start with an example of what we were doing in the previous section. So remember, we want our leading coefficient to be 1. So if it's not, we're going to divide everything by whatever it is. So in this case, 4. So we're dividing everything by 4. So that's going to give us x squared plus 2/4 x. Sorry, blurred up on you. Which remember, 2/4 is the same as 1/2 x. Okay, and then minus 5/4. And then remember, the other part with completing the square is that, 0 divided by 4 is still 0. We want the constant moved to the other side, and then we are going to add b over 2 squared to both sides because that completes the perfect square trinomial, which then we can factor. Okay, so b over 2 squared. So b over 2 is dividing by 2, right? So 1/2 divided by 2 is 1/4. 1/4 squared is 1/16, right? We square the top and square the bottom, okay? And then I add that b over 2 squared to both sides, okay? Then it factors. B over 2 was 1/4, so plus 1/4, okay? And then over here, I need to get a common denominator. So I'm going to multiply both these by 4 so that my common denominator is 16. So I get 20/4 plus, 20/16 plus 1/16 is 21/16. Okay, now we're going to take the square root of both sides. And I am going to continue this up here. So the x plus 1/4 on the left is because the squaring is gone. Square root of the top is just square root of 21. It's not a nice perfect square, but square root of 16 is 4. And don't forget that plus or minus. Okay, now I'm going to subtract 1/4. And because they have the same denominator, I can write it as a single fraction. So -1 plus or minus square root of 21 all over 4. All right. Okay, now we're going to talk about how to use completing the square to put quadratics into vertex form. Okay, so here, this is our vertex form of a quadratic, right? Where h and k are my coordinates of the vertex, and a is the stretch factor. And we use that graphing. We multiplied a times the 1, 3, 5 pattern. Okay, so we're actually going to try and convert our quadratic in standard form to vertex form, and we're actually going to do that by completing the square. Okay, so what we're going to do here is there's kind of two options. You can put a 0 in here for f of x and move the constant over, or you can do it all on one side. So I'm going to show you how to do it on the same side. Okay, so here I'm going to put the blank in like I normally do after the x squared and x, but then I'm going to keep the 20 over here. Now, whatever I added here, because right now I'm on the same side of the equal sign, okay, and I'll actually move that closer so it's more obvious that I'm on the same side. Okay, so whatever I add here, I'm going to add here as well, but then that makes my equation totally unbalanced, right? I'm adding essentially double something over here and then nothing on the left side. So what I'm going to do, if whatever I'm adding here is b over 2 squared, I'm going to subtract b over 2 squared here. And the reason for that is, you guys, is we are essentially then adding 0. If I'm adding b over 2 squared here and subtracting it here all on the same side of the equal sign, we haven't changed the value of the equation at all. The purpose of doing this is just to change what it looks like. So let's see what this does. Okay, so I'm going to factor this normally after I add b over 2 squared. So b over 2 is 6. Squared is 36, and so I'm adding 36 here and I'm subtracting it here, okay? So this part, remember, will always factor into b over 2 with the x, so that's 6 quantity squared. And over here I'm going to simplify this. 20 minus 36 is -16. So the reason why I like to do it all on the same side is because now this is in vertex form, right? My vertex, remember, it's always opposite of this sign here, so it's going to be -6. for my x-coordinate, and then that sign stays the same for my y-coordinate. And then my stretch factor is just 1. So my regular pattern for graphing would be still 1, 3, 5, okay? So that's the purpose again of completing the square. I do it on the same side, but then it's in that nice vertex form that we're used to seeing. Okay, let's try this one. All right, well this one, if I think about kind of how this has moved using transformations, right? This one has moved up 3. So my vertex, I could think about it as this, right? So this one's kind of already in vertex form. So my vertex is 0, 3, and my stretch factor is still 1. So this one, sometimes we might not have to complete the square, and that's if I'm missing that b term. We can just see how the quadratic has shifted vertically, and that's just going to affect our y-coordinate. Okay, let's try another one where we have to complete the square. All right, so we want to put this in vertex form and identify the vertex. So we are going to set up that same part. I'm going to leave the 10 kind of off to the side here. And remember, whatever I'm adding here, I'm subtracting here. So I have a positive 1 and a negative 1. And what it's going here is b over 2 squared. So b over 2 is negative 3, squared is 9. So I'm adding 9, subtracting 9. This part factors. B over 2 is negative 3. And then negative 10 minus 9 is negative 19. So this is my function in vertex form. So then my vertex I can easily pick out is 3 and negative 19. And my stretch factor is just 1. Okay, now this one, we have an a that is not 1. So what I'm going to do here is I am going to just take out the 2 from the x's. And the reason for that is because remember a, I'm going to flip back here really quick. A is just affecting the x and the x coordinate. So I'm kind of leaving the constant here off the side. So I factored out a 2 out of the x squared and the x. And then I'm leaving the 13 here. Okay, so I'm still adding b over 2 squared and subtracting b over 2 squared. But there's going to be one slight difference here when a is not 1. Okay, so let's see what happens here. So I'm looking at this interior quadratic. Okay, so I'm trying to make a perfect square trinomial. So 6 divided by 2 is 3, squared is 9. Now because the 9 is in this set of parentheses, this 9 is really being multiplied by 2. So really what I've just changed this whole equation by is 2 times 9, which is 18. So I need to do that here as well. Okay, so I didn't just add 9, I added 2 times 9. Okay, so now what happens? Okay, so factor, b over 2 is positive 3. And then I just need to follow order of operations. So this is 18. 13 minus 18 is negative 5. So that is our function in vertex form. So my vertex is negative 3, negative 5. My stretch factor is 2. So my pattern instead of 1 through 5 is going to be 2, 6, 10. All right. Looking at this last one, we also need to factor out negative 1. So it has to be a positive 1 for an a, not a negative 1. So I'm also going to factor out negative 1 here. And again, I'm just going to do it on the x's, the x squared and the x. So I'm taking out negative 1. So that's all it does is it changes the sign. Okay, I'm leaving room. All right, so looking inside here, b over 2, negative 2 squared, positive 4. Okay, but I have 4 times negative 1, so I also need to be subtracting 4 times negative 1 here. Okay, so negative 1, b over 2 is negative 2 squared. Order of operations, negative 4 times negative 1 is positive 4, so 10 plus 4 is 14. So my vertex is 2, 14. And A is -1, so that means it's going to open down, but I'll still have that pattern of 1, 3, 5. All right, guys, that is it for converting to vertex.